Today let's continue talking about the bits of information. Last time I explained that the singularity inside the black hole is a bit of information, and I called it quantum bit of information. But there are so many definitions that can be given to this singularity. Therefore, we said also that the singularity is a small box of space-time which preserves the information of the star and all the objects that fall into the black hole as a number. So inside this box there is a number, and the number is associated to the box, so we cannot separate them. When a number works, the number vibrates, then this number will split into 4 junior numbers. These numbers all, as we know, are complementary numbers. I mean, A and B make S, C and D make S. So we have 2 pairs of complementary numbers. This gives us the structure of a quantum bit, or a bit of information in space. So it means that the bits of information are there. We don't need to make them. We don't need to create them. All we have to do is to find them, because they are naturally made in the universe. And in order to find them, we have to refer to this 400 years old experiment. Galileo was so much concerned about the rate of falling objects. And he's the one who discovered that if you remove the air and all other obstacles, all the objects fall at the same rate. And to confirm his experiment, he had to measure exactly the speed the objects fall. At what speed they fall down. Then he made this realm. This is an instrument that he made by himself, and he had a very beautiful ball, and he will roll this ball along this realm. Then he will measure time and distance. In our terms, we will say time and space. Then, when he rolled the ball once, of course, if you go a full tour of this, so you will cover the circumference of the ball up to point 1. And he marked this point as the unit of distance and unit of time. So in time, 1 gives him 1. Then he rolled the ball for 2 bits of time. Then he found out that the ball rolled 4 times. When he rolled it for 3 bits of time, then the ball rolled 9 times. Then he established a relationship between time and distance. In our terms, time and space. That if my time is 1, the distance will be 1 squared. 2, 2 squared. 3, 3 squared. So this is the relationship. Therefore, he concluded that the distance the ball traveled, or an object travels in a free fall, equal to the time squared. So this is the formula that have led to so many inventions. But what is important to us here? For us, we are seeking for information. And information is all about considering the numbers. Because here, as you see, the ball can be any size. It can be the size of a basketball, of a tennis ball, of the planet Earth, of the sun, of the universe itself. So, it's anything you can use. So what is important to us here is the number. Then, speaking of numbers, let's see what happened during the fall. During the fall, the object or the ball rolled once here. So one event. During the second bit of time, the ball rolled 3 times. During the third bit of time, the ball rolled 5 times. So we have 5 events here, 3 events here, and 1 event here. It means the object is accelerating. Because of this acceleration, we are concerned about the instant, the moment, because the moment is more precious for us to know how fast the ball is traveling at a certain point in time. Then here we have to know it mathematically. We know that during the first bit of time, the ball traveled once. It goes from 0 to 1 in time. Then number of events is just 1. Where the 1 came from? 1 came from 0 plus 1. During the second bit of time, the ball traveled 3 times, or we have 3 events. Where the 3 events came from? 1 plus 2. During the third bit, the ball traveled 5 times, or 5 events. It means 2 plus 3. Then if we go to the fourth time, then we will have from 3 to 4. It gives us 3 plus 4 equal 7. The next will be 9. Next will be 11. And it will continue on. As you see, we can say that the number of events describe the surface area of space-time for storage of information. Then we can just notice, based on numbers, that when an object moves between 2 consecutive points, like here, it goes from 3 to 4, the number of events is 3 plus 4, 7 events. So this is the space time. The space between 3 and 4 in space-time, it is 7. Then you can do it for every 2 numbers. If you have space between 9 and 10, then you get 9 plus 10. Between 20 and 21, 20 plus 21. But let's say now that we go from a point like 3, then we go to a distant point, which is 8. Between 8 and 3, there are numbers here, which are 4, 5, 6, 7. Then how to tell the number of events? In order for us to tell the number of events, we have to open the space between. So what we will do, we will split or we will duplicate these values here between 3 and 8 to create a space, to create a compound. This becomes known as the compound of 3, 8. So how much information we have in this space? How many events we have from point 3 to point 8? You just sum up all these numbers. Then they give us 55. They give us 55. Then, now, we will see that this is our storage in this compound of 3 and 8. It gives us a bit of information. So how much information we can store between 8 and it gives us 55. And how it was calculated, I told you already that you had to sum up all these numbers together. Then, that's not enough, because it is not yet the bit of information. We know the value of this bit, but we have to find its structure. And in order for it to show its structure, we have to produce the 2 pairs of complementary values. And how to do it? We have this, from 3 to 8. And these are the values between. We need to produce 4 numbers here. The first number will come up, here, up. How to get it? Get all the values in yellow. Sum them up. 4 plus 5 plus 6 plus 7 equal 22. Put it there. Then you have to find the complementary of 22 based on 55. What is the complementary? 33. So you get 55 minus 22. That's 33. And where the 33 comes from, you get all these values together as one. Put them in a box there. And that's 33. We still need 2 more values to find. The one that will be on the left should be coming from, go from 7 down to 3. That gives us 25. The sum of all of this is 25. Now, to find the number, the complementary of this one, based on 55, so we have 55 minus 25 equal 30. So, what are the numbers involved? 4 up to 8. 4 up to 8. That gives us 30. So you see that it's very simple. This is a very simple thing to do. We just only use numbers, then now we found already the structure of a quantum bit of information. And if you want me to present it to you, if you have number 55, and this number 55 will express itself with child numbers, then these are the 4 child numbers. The 4 are 22, 33, 25, 30. Then they have differentials between them, and these are numbers that separate them. These are 3, 8, 8, 3. So these are the differentials between them. And this gives us the structure of a quantum bit. Why? Because actually this number here is not visible. This is a ghost number in reality. When this 55 will be working, it will express itself through this. Therefore, you can't see it. That's why we talk about hologram. So what we have created here is a hologram already. 55 is invisible number. It is a ghost number. You can't see it. Therefore, if you go to the table of information of the universe, you will never see 55 on the surface. But 55 is there. Just like the singularity, if you go there, you go standing in front of the black hole, you will never see the singularity. But the singularity is there, deep inside. So if we go back to the whole map, we will find that there are other numbers that are connected to this. And all these numbers can come up here, 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 there. So we will have a whole table of numbers. And they will make what we call the universal table of information. This universal table of information exists. It is there. I can make it out of this already. I can continue to make it until I will make all. But making all, how many years it will take? Of course, we will be cutting only portions. So we can make some, then we will be guided. Actually, I have more explanations to give about this. But this is not the time. So we will be having more bits. This bit, because this 55 there has connection with 4 other neighbors below there. And if we go deeper again, we go deeper and deeper until we reach the singularity. So this is what we have discovered. Now we have 3 bits of information, and these bits are all quantum bits. It means the energy from 35 can split this way or that way, vertically, horizontally. That's what particles do. So if you understand what gravity now has revealed to us, then you are looking for quantum gravity, you have a clue. I will not speak. I will not give you my viewpoint at this point. I will not tell you now. No. Study first and understand this. If you understand this one, then we can talk about quantum gravity. Because this came from Galileo's experiment. But anyway, the video that helped me to relate my discovery to Galileo's experiment came to me 3 years after I found already this. Therefore, there is a fundamental, a deeper explanation of all of this based on the singular numerical relativity by itself. But I used Galileo's experiment just for you to relate easily. I used it for you to relate easily, to show you that the singular numerical relativity is describing gravity. That the relativity based on numbers is the best for us to explain gravity. You have seen that we don't need to make any effort normally to find the bits of information. And how we can find them, I have demonstrated how the numbers work. Therefore, up to you to decide. If my explanation is not enough, ask me questions. I can still explain more. But I have given you the clue of quantum gravity, if there is. Because we have gone back to Galileo And Galileo has told us that his experiment is good enough to explain quantum gravity. So, please, I can't say more. I have no words to tell anyone something else. All I have to do, all I can tell is study the singular numerical relativity. You can never resolve the problem of quantum gravity without studying this. The only way is this way. So, please join me and study the singular numerical relativity. Thank you.